How much power is your Plex server using? 100 watts? 200 watts? More? Is your server a power guzzling machine, or does it sip only the power that it needs? With energy costs soaring and processors getting more efficient, it might be a good time to rethink your current Plex server hardware, or at least make it a little more efficient by adjusting some common settings. In today's video, I'm going to show you how to build and configure an efficient Plex server that doesn't skimp on processing power, storage, or features like transcoding, all while only using 16 watts of power. I'm taking a holistic approach to efficiency, handpicking every single hardware component and analyzing and tweaking every setting with efficiency in mind. With this build, I want to make sure that we still enjoy the same performance and features from Plex, all while reducing our carbon footprint and maybe even saving a little money on our energy bill. Oh, and I figured it should look good too. So join me as we break down the hardware configuration, software, operating system, and power settings to build a super efficient Plex server that can serve all of your media, but at a fraction of the energy cost. I want to thank Plex for inviting me back to Pro Week. Last year, I shared the ultimate guide to live TV and DVR with Plex, and I'm excited to return to share my deep dive on building a more efficient Plex server. I know that energy use has been on my mind, so I hope that you find this topic interesting too. And if this is your first time seeing me, hello. I'm a tech enthusiast who loves to build and network home servers, run self-hosted services, I love RGB lighting, if you couldn't tell, and I even love sharing tutorials on some pretty interesting tech. If you'd like to see more videos on topics like this, check out my YouTube channel after watching this video. One of the first choices you'll make when building a Plex server is hardware. This choice will have the biggest impact on your energy use, and you'll be surprised on how little you actually need. I'll discuss my choices on my new build and why I chose them, but feel free to swap these parts out as you see fit. First is our CPU selection. Now, my choice for a CPU isn't the one with the most cores, the most features, and the highest clock speed. No, it's quite the opposite actually. I look for a modern processor that has the least amount of cores, lower clock speeds, and integrated power saving features. I chose an Intel Core i3 14th gen processor for all of these reasons and because it has an integrated GPU. Wait, an integrated GPU? Don't we need a dedicated one? No, we actually don't need it for Plex transcoding. QuickSync is a technology from Intel that allows you to transcode video for Plex efficiently and without the need for a dedicated graphics card. This not only saves us money, but also saves energy. For those who aren't sure what transcoding is, in Plex terms, transcoding means converting a video from one format to another if the device that you're viewing it on is not compatible. Let's say, for instance, you have a 4K video on your Plex server. However, your Roku TV only supports 1080p. To watch this video, Plex will transcode the video in real time to make it compatible with your Roku TV, so you can still watch the content even if the device you're watching it on isn't compatible. While transcoding on the CPU is free, transcoding on the GPU is a premium feature, so you'll need a Plex Pass to do it. We'll talk more about transcoding and optimized settings later, but by choosing this CPU with QuickSync means that we can efficiently transcode when needed. After choosing the CPU, you'll have to choose which motherboard you want. You have a variety to choose from, but you'll just want to be sure that it matches your CPU socket. When choosing one that's low power, I often look for one that's smaller, has less components, and limited expansion slots. This ensures that there aren't any components being powered that won't be used. You'll also want to be sure that it has enough ports for your drives. I ended up choosing a micro ITX board because there typically isn't any wasted space on these boards. This board that I chose from Asus fits the bill. It has 4 SATA ports and 2 M.2 slots, which should be plenty for our Plex server. Now, we do have a PCI Express slot that you can see here at the bottom that won't be used, but that's less than the 3 to 5 you typically see on other boards. Plus, it's good to have one slot just in case you need to add more components like drives or graphics cards later. Next is RAM selection, and it's pretty straightforward. Well, for the most part. Let me explain. First, I would just choose memory from a reputable brand. But right now we're in a weird time when it comes to memory selection because you can get both DDR4 and DDR5. And although I struggled with the decision due to cost and performance, I decided that if I'm going to build a brand new machine, I'm going to go with the latest technology. So I ended up choosing a pair of 32 gig DDR5 sticks from Corsair, which will give me 64 gigs of RAM, which is more than enough for this build. As far as storage is concerned, we have more options than you would think to choose from. With each choice, we have to balance capacity, cost, power consumption, and performance. On one end of the spectrum, you have NVMe SSDs, which use a considerable amount of energy, but are the fastest option, yet the most expensive, and typically lower capacity. On the other hand, you have traditional spinning hard drives, which also use a considerable amount of energy, but are the slowest option, yet the least expensive, and higher capacity. Then in the middle, you have SATA SSDs, which offer much less power usage than the other two. They're medium speed, medium cost, and medium capacity. This choice really comes down to how much you want to spend on storage. I think for my build, I'm going to use an NVMe SSD for the operating system and applications, and a traditional spinning hard drive for bulk storage, which is my Plex Media library. Now, I'm only using one spinning hard drive, but you might want to add another hard drive to mirror your data in case one of these hard drive dies, or at least back it up to another machine. Another consideration when building a low-power Plex server is the power supply itself. Power supplies come in a few shapes and sizes, but one thing you'll want to consider is the energy efficiency rating. This rating is something you'll find on all power supplies, and it goes from a plus rating at 80% efficiency all the way up to a titanium, which is 94% efficient. The higher the rating, the more efficient and the less heat it generates when converting power from AC to DC. The price also increases the higher the rating you go. I ended up choosing this small form factor power supply because of its platinum efficiency, its modular cable design, and because of how small it is and it will fit nicely in this case. The one nice thing about this power supply is that the cooling fans never turn on based on the power draw of this system, so it's dead silent. When choosing a case, some go for looks and some go for functionality. I usually choose somewhere right in the middle but lean towards functionality, but for this build, I wanted to do something a little bit different. I wanted a server that blended in with my living space, so I chose this Fractal Terra case, which is modern, sleek, and isn't an eyesore if it's in my living room. This case not only looks good, but is also able to fit all of the components that we're using today. With all of these components in such a small space, we'll want to be sure we have adequate cooling, especially for the CPU. CPUs typically come with stock fans, and that should be fine for most low-power builds, but I always upgrade the CPU cooler to an aftermarket cooler like this Noctua one. Generally speaking, aftermarket coolers offer better cooling and are much more efficient. I paired this cooler with some good thermal paste, and now I have a nice compact solution that will keep this CPU cool and quiet. Another option is case fans. The case you choose may come with adequate cooling and fans. However, if it doesn't, I would recommend getting some that not only keep your build cool, but also keep it quiet. And again, I usually recommend Noctua here as well. Check it out! We now have a fully built system that's ready to start running Plex, but we're not all the way there yet. We still have a few more things to tweak even before we install anything on it. We need to power the system on and check out some of the options we have in our UEFI settings. People also call this BIOS, but the concept is still the same. You can typically get into your BIOS when your machine boots by hitting a designated key. Once in, we can change some of the settings. Now, I'm going to preface this whole section with caution. You should only change these values if you know what you're doing, and most of the things I configure only give me minimal gains. These settings are also not available on every motherboard, so change these at your own risk, and when in doubt, just keep the defaults and skip this section altogether. Now, with that out of the way, one of the biggest gains you're going to get is just by updating your BIOS. You'll want to check with your motherboard manufacturer on how to do this. After updating the BIOS, here are the things I look for to adjust for a low power system. First, if you're using Intel, I make sure that speed step is turned on, and if you're using AMD, make sure that cool and quiet is turned on. This ensures that the system can adjust according to load. I also make sure that the fan control is set to smart based on temperatures, but I skew towards silent. I disable multi-threading or hyper-threading, and I disable turbo boost because I don't want my system to clock higher than the base clock speeds. This saves power consumption with very little impact on performance. For really advanced users, if you have a motherboard that supports it, you can also underclock your CPU and memory speeds, resulting in less energy use and much cooler temperatures. Beware though that this can also affect stability, and we'd rather have a stable system than an unstable system. There might be other settings your motherboard supports like USB power management, thermal throttling, and many other settings which may or may not have an impact. The CPU, RAM, and fan speed settings are where you're going to see the most energy saved, so I would probably stop there. As far as operating system selection goes, you have quite a few options here. You can go with a Linux server or Linux desktop if you want to stick to an open source build, or even a NAS operating system if you want to use it for multiple purposes. But for this build, I'm going to go with Windows to see if I can tune it, not only to be efficient, but also performant. Again, feel free to choose what works best for you. By the way, I did test the power settings with Linux too, so I'll have some comparison on how Windows did versus Linux later on. Once you have Windows installed, you'll want to be sure that you have the latest drivers. Your motherboard manufacturer should have them for you, but I've also found that the Intel Driver Assistant and the AMD Auto Detect tools might have more current drivers for your system. Windows does have quite a few ways to manage power for all of our devices, but before we dive into some of the traditional ways of managing power, let's start by disabling some devices. If your motherboard has Bluetooth, Wi-Fi, and possibly NFC, and you don't ever plan on using them, you can easily disable all of them by simply turning on airplane mode. This is a simple way to toggle off all wireless communications. You can also turn these off in UEFI or BIOS settings, but doing them here in Windows makes it easier to toggle them back on if you ever need them. I would also recommend unplugging any USB devices that aren't being used, but only after we're done configuring a machine, of course. Windows makes it really easy to change your power plan settings with their new energy recommendations. However, we want more granular control over these settings. So rather than have Windows do this for us, we'll create our own custom plan. You can find this by searching the Start menu for Power Plan and clicking on Choose a Power Plan. Once here, rather than editing an existing, let's create our own plan. Let's base the plan off Power Saver Plan, and you can name it something like Max Power Savings. We'll want to turn off the display after 1 minute and never put the machine to sleep. If our Plex server went to sleep, we would no longer be able to access our media, so we want to be sure not to enable sleep or hibernate. Once created, let's change the plan settings and change the advanced power settings. As far as hard drive sleep goes, I feel that 20 minutes is pretty good. What we don't want to have happen is our drive spinning up and then spinning back down over and over, because this not only leads to unnecessary wear, spinning up the drive consumes a lot of energy too. For Internet Explorer, which isn't even applicable anymore, we'll want to set it to max power settings. Desktop slideshows should be paused, and wireless adapter settings should be maximum power savings. If you've already disabled your Wi-Fi adapter, you don't really need to worry about this step. Sleep and hibernate settings should be set to never, because we don't want our Plex server to go to sleep, and USB suspend should be turned on so we can disable USB ports that aren't in use. For the Intel graphics settings, you can set this to maximum battery life. However, this shouldn't have any effect on our desktop system since we aren't running on battery. You can also set the link state power management to maximum power savings. Now, this might have a performance impact on our NVMe drives that we're using for our OS, but it should be minimal while keeping our power usage low. Also, we aren't populating the PCI Express slot, so no effect there. The next couple of processor settings are related to Turbo Boost. If you remember, I disabled this in our UEFI settings. However, if you didn't, here's where you can control it. Many recommend that setting the maximum processor state to anything less than 100% should disable Turbo Boost on our CPU. Since I have it disabled in BIOS, I don't need to configure it here. However, if you set it to 99%, you'll see that the turbo is essentially disabled. I would only tweak the setting after Plex is set up so you can see if it has any impact on your Plex experience. Continuing on, we'll want to turn off the display after 1 minute of inactivity, and for the multimedia settings, which don't really apply, we'll want to set them to prevent idling to sleep, video playback power savings bias, and optimize power savings. These really don't apply because we're never going to sleep, and we're also never going to be playing a video locally in a desktop environment. At this point, we have our hardware working great, our operating system tuned, and now it's time to download and install Plex and configure our media libraries. We don't really need to do anything out of the ordinary here. We can follow the instructions on Plex's website. One thing to note is that you will want to install Plex on your fastest hard drive, which in our case is the NVMe drive. This will help in two ways. One, it will ensure that our media library metadata is on our fastest drive so that browsing our media is fast and responsive. Two, it will ensure that our media disks can go to sleep or spin down to save power when they aren't being used. Once Plex is installed, configured, and running, we'll want to go to our Plex server in a browser and go to Settings. So head down to the transcoding section on the left. Now, before we make changes to transcoding, it's a good time to mention that the best transcoding is no transcoding at all. So what do I mean by that? Well, whenever possible, we want to direct stream our media. This means that both your media and the device that you're using to view the media support the same codecs, so no transcoding is needed at all. This is the ideal scenario because it doesn't need to transcode video while watching, which means it will use considerably less power. However, when we do transcode, we still want to make sure that we're doing it on the GPU whenever possible, since it's much more efficient than transcoding on the CPU. We can adjust these settings in the transcoder section by showing advanced settings. Now, I set the quality to automatic, which will let the server select automatically. I haven't seen a need to change this, and this is the recommended setting by Plex. I set the background transcoding to very fast. Now, this setting is only used when syncing media or optimizing it, so it's not a feature I use, but if you do, fast is a good balance between quality, speed, and file size. I enable HDR tone mapping, even though I don't have any HDR content. I use hardware acceleration when available, meaning that it will use my GPU to transcode rather than my CPU. And then I also turn on use hardware accelerated encoding, which will ensure that the GPU is also used for encoding media too. You can also choose how many simultaneous streams to support, however, I just set mine to unlimited. Okay, so we've built our Plex media server with efficiency in mind. We've tweaked the hardware settings, the OS settings, and even Plex itself. So how does it perform and how much energy are we using? Well, at idle usage, we're only using around 19 watts of power and only 16 watts of power when the drive's been down. This is crazy. This is awesome. Like, I never would have thought I could build a PC like this and use 16 to 19 watts of power. Can you tell I'm excited? The way I measured this was by booting Windows, logging in, disconnecting all peripherals and network, and then letting it sit for about 25 minutes before measuring. I used a wattage meter that gives me instant readouts, and I also measured it over time with a smart plug. This is pretty awesome considering my desktop uses around 90 to 95 watts of power. Oh, and remember how I mentioned Linux earlier? I also tested it too, and I was super surprised at the results. When using Ubuntu server, I saw it hanging around 17 to 18 watts of power when idle, and when using Ubuntu desktop, I saw the same thing, 17 to 18 watts of power. This was surprising to me because I thought for sure that Windows was going to use much more power than Linux variants. However, I think this shows how optimized Windows and Windows drivers are. This totally busted a myth that I've had in my head for many years that Windows at idle uses more power than Linux at idle. At least Ubuntu. The next question I needed to answer was how much power does it use when it's transcoding one video? After the machine was idle, I started streaming a video and transcoded a 4K video down to 1080p. You can see here that it's using QuickSync from the integrated graphics on my Intel CPU, and it's only using 28 watts, which seems pretty good. Only about 9 watts of power to transcode this. I'm comparing it to the 19 because it doesn't really count if the drives are spun down because you have to spin up the drives to watch media. But 9 watts is pretty awesome and pretty good. The next question I think we're all wondering is, how many simultaneous transcodes can it support? Well, I tested that too. Using the same video, I streamed more and more videos at 1080p until I started to see a stutter. I didn't see a stutter until I transcoded 11 sessions at once, which is pretty impressive for the lowest model Intel CPU without a dedicated video card. When transcoding 11 streams, the power usage did spike to 58 watts, which is much less power than I would have imagined. Now, this many streams is pretty atypical for my home. Rarely do I need to transcode more than one stream. But if you find yourself needing to transcode the same video often and you have the disk space, you might want to optimize this video so that future viewings won't need to transcode it on each play. This is handy if you have kids' videos that are watched over and over and over and over and over and need transcoding. If you optimize this once, you won't need to transcode it again. So this build blew my mind, and it turned out much better than I originally imagined it would. This custom-built PC is pretty efficient for a Plex server and still gives us all of the features we need. We're able to run Plex Media Server only using 16 to 19 watts of power, and even have the ability to transcode our videos anytime we need for about 9 watts more. You could of course make changes to this build according to your needs, and you might even save a little bit more power. That being said, I think now more than ever we should pay attention to the power that we're using and choose efficient solutions whenever possible. If I had more time, I would put this custom-built PC up against a smaller mini PC like this one to see how much power savings we get by using this instead. Maybe in a future video. I want to thank Plex again for inviting me back to Plex Pro Week and for sponsoring this video. I'm Tim. Thanks for watching.